We now discuss the solution of a problem from the section Binomial Theorem. The problem is related to the binomial coefficients. This question has appeared in the joint entrance examination main held on 28th June 2022 in the first shift. The given question is, if sigma k is equal to 1 to 31 of 31 ck multiplied by 31 ck minus 1 minus sigma k is equal to 1 to 30 ck multiplied by 30 ck minus 1 is equal to alpha times 60 factorial by whole by in the denominator 30 factorial multiplied by 31 factorial, where alpha is a real number. Then the value of 16 times alpha is equal to, we are given four options. Option A 1411, option B 1320, option C 1615, option D 1855. So we are given sigma k is equal to 1 to 31 of 31 ck multiplied by 31 ck minus 1 minus sigma k is equal to 1 to 30 ck into 30 ck minus 1 is equal to alpha times 60 factorial in the numerator by in the denominator 30 factorial into 31 factorial, where alpha is a real number required to find the value of 16 alpha. That is the given question, and this is given for your ready reference. We now discuss the solution of the problem in detail. We take sigma k is equal to 1 to 31 of the binomial coefficient 31 ck multiplied by 31 ck minus 1. That is written as that, this one we have taken, and it is equal to, we have written as AB is equal to BA. That is the commutative law we have applied, because these are numbers. These are natural numbers actually. So 31 ck multiplied by 31 ck minus 1 we have written as 31 ck minus 1 into 31 ck. Agreed. For this 31 ck we will write 31 c 31 minus k. So what are we using? We are using the fact NCR is equal to NCN minus R. Here n is 31, R is let us say k. Then we will write NCN minus R, that is 31 C 31 minus K. So for this we write 31 C 31 minus K. Right. Now expand. So let us put K is equal to 1. So we will get, if you put K is equal to 1, 31 C naught C0 multiplied by 31 C 31 minus 1 30 plus K is equal to 2 31 C1 multiplied by 31 C 29 plus etc. We go to K is equal to 31. When you put K is equal to 31 C 31 minus 1, that is C 30 multiplied by 31 C 31 minus 31, that is 31 C naught. So that's what we got. So the given the summation of the product of the binomial coefficients now is written like this, that they are equal. Now let us recall the expansion of 1 plus x to the power of 31, the binomial expansion. So this will be sigma k is equal to 0 to 31 ck into x to the power of k. This is the well-known binomial expansion to us. Agreed. Expand this. If we expand 31 c naught plus 31 c1x plus etc. etc. 31C29 x29 plus 31C30 x30 x power 30 plus 31C31 x power 31. This is the well-known binomial expansion what we have. Right. So we consider the coefficient of x to the power of 30 in 1 plus x to the power of 31 multiplied by 1 plus x to the power of 31. So the coefficient of x to the power of 30 in, take this first one, write its expansion, this expansion we have written, multiplied by the second one, the expansion. So you have to consider the coefficient of x to the power 30 in this product. So how do you get it? How do you get it? So here 31C0, that is 1 times of 31C30 x to the power of 30. Then the product 31C0 into 31C30 is the coefficient of x to the power of 30. And like that you have to pull up all those things. So this one 31C0 multiplied by 31C30, that is the x to the power of 30 coefficient. So write down, plus you take 31C1x, we got x here. To get x to the power of 30, get the coefficient of x to the power of 29. So 31C1 multiplied by 31C29 will be the x to the power of the coefficient of x to the power of 30. So this multiplied by this, then you will get 31C1 multiplied by 31C29 is the coefficient of x to the power of 30. So like that it will be advancing like this in this direction, and it will be, it will be coming backwards like this. So go on. So etc. We move etc. 31C30 x to the power of 30 multiplied by 31C0. So plus etc. 31C30 multiplied by 31C0. So what is this? This is precisely this one. This is same as this one. So therefore the coefficient of x to the power of 30 is sigma k is equal to 1 to 31 ck into 31 ck minus 1. That is this one. Agreed. This is the coefficient of x to the power 30 on one hand, that is multiplying the expansion of this multiplied by this expansion and collecting the coefficient of x to the power 30. Now take this, multiply, you will get 1 plus x to the power of 32. In that, collect the coefficient of x to the power 30, and they must be equal. So on the other hand, the coefficient of x to the power 30 in 1 plus x to the power 31 multiplied by 1 plus x to the power 31 is equal to 1 plus x to the power of 62 will be 62C30. That will be the coefficient of x to the power 30 in 1 plus x to the power of 62. They are one and the same. See, by this one, on the other hand, this one. So they must be equal. So, but this one is in the sigma notation, you write sigma k is equal to 1 to 31. 31 ck into 31 ck minus 1. This is this one. This is equal to this, equal to this. Is equal to 62C30. So this is what we have the derivation for this one. That is, in one sense we have evaluated. So similarly, sigma k is equal to 1 to 30 ck multiplied by 30 ck minus 1 will be when it is 31 2 times 62. So it is 32 times 60 C 31 minus 1. So it will be 30 minus 1, that is 29. So this summation is this answer, this summation is this answer. We continue in the next slide. Right. So we have this sigma k is equal to 1 to 31 ck into 31 ck minus 1 is equal to 62C30. And similarly, sigma k is equal to 1 to 30 ck into 30 ck minus 1 is equal to 30C29. Agreed. Now look at the question. You have to subtract. So subtracting the first one minus the second one is equal, first one is 62C30 minus the second one is 60C29. So this is the left hand side. But it is given this is equal to this one. Given this one is equal to alpha times 60 factorial by 30 factorial into 31 factorial. So therefore, we must have 62C30 minus 60C29 is equal to alpha times 60 factorial by 30 factorial and 31 factorial. So that's what we get it. That's what we get it. Right. Now we have written 62C30 as 62 factorial by 30 factorial into 62 minus 36, 32 factorial. But that 62 factorial we have written as 62 into 61 into 60 factorial minus 60 factorial by 29 factorial into 60 minus 29, that is 31 factorial. This is equal to alpha into 60 factorial by 30 factorial and 31 factorial, as it is we have written. Now what we see is 60 factorial in the numerator, throughout it is there, cancel, and then multiply both sides by 30 factorial, 31 factorial, then you will get alpha. So alpha is equal to 62 into 61 by 30 factorial into 32 factorial multiplied by 30 factorial and 31 factorial. We have cancelled 60 factorial, mind you, minus 60 factorial is cancelled, 30 factorial into 31 factorial by 29 factorial into 31 factorial. Agreed. 30 factorial cancels here. Agreed. Now 31 factorial, 32 factorial. 32 factorial is written as 32 into 31 factorial. 31 factorial cancels. So what you have is 62 into 61 by 32. And here 31 factorial cancel. 30 factorial is written as 30 into 29 factorial. So 29 factorial cancels. So what is remaining is 62 into 61 by 32 minus 30. You can see very easily. 30 factorial cancels. 32 factorial we have written as 32 into 31 factorial. 31 factorial cancels. So you got 32. So 62 into 61 by 32. Correct. Here 31 factorial cancels. 30 factorial is written as 30 into 29 factorial by 29 factorial cancels, and you get 30. So now what is that we want? We want 16 times alpha. 16 times alpha is 16 into 62 into 61 by 32 minus 16 into 30. Simplifying, we will get 31 into 61 minus 480. That is 1891. That is the multiplication of 31 into 61 minus 480. That is, after simplification, we will get 1411. Now look at our options. Our answer 16 alpha is equal to 1411 appears against option A. Therefore, the answer for this question is option A. That is the detailed discussion of the solution of a problem which is related to the binomial coefficients from the section binomial theorem. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.